This apex predator of the North American wilderness deserves to be called one of nature's most contradictory survival machines. Its range once stretched from the Great Plains to the Pacific coast, from the deserts of Mexico to the edge of the Arctic. It carries a sense of smell roughly 7 times more powerful than a bloodhound's, paired with a body that can rearrange its own biology twice a year, once to store fat fast enough to double its own weight, once to survive 7 months without eating, drinking, or standing up. Features that serve as the key to one of the strangest survival strategies the animal kingdom has ever produced. This is the grizzly bear, scientific name, Ursus arctos horribilis. Within the order Carnivora, the grizzly is among the largest land predators in North America, an animal built with the jaw, the claws, and the raw strength to kill almost anything on the continent. And yet, in many inland populations, plants make up somewhere between 80 and 90% of what it actually eats in a given year. Roots, grasses, berries by the hundreds of thousands. A carnivore by classification and by weaponry that spends most of its life quietly outperforming a cow. That contradiction is exactly why this animal is so much harder to predict than people assume, and why understanding it changes what apex predator even means. The scale of what's actually left of this species tells its own story before any attack statistic does. When European settlers began moving west, an estimated 50,000 grizzlies roamed the lower 48 states alone, ranging as far east as the Great Plains and as far south as northern Mexico. By the 1970s, hunting, trapping, and habitat loss had reduced that number to under 1,000 individuals, confined almost entirely to the Yellowstone and Glacier ecosystems, a decline of more than 98% in under a century. Federal protection under the Endangered Species Act in 1975 slowed the collapse and, over the following 5 decades, allowed a genuine recovery. Greater Yellowstone alone is now home to more than 1,000 bears, a rebound conservationists consider one of the significant wildlife recovery stories in American history. But recovered here still means a species confined to roughly 2% of the range it once occupied, in landscapes now crossed by roads, ranches, and hiking trails that didn't exist when the population was intact. Nobody goes into bear country without knowing the risk. That's the kind of line wildlife officials across Montana and Wyoming have repeated for decades, and the data backs up why. Grizzly bear researcher Stephen Herrero, whose work remains the foundation of nearly everything modern science understands about bear attacks, spent decades cataloging incidents across North America, work that grew out of a landmark 1970 paper he published in the journal Science Analyzing Human Injuries Inflicted by Bears. The pattern that emerges from that research isn't random cruelty. The overwhelming majority of serious grizzly attacks are defensive. A surprised bear at close range, a female protecting cubs, an animal defending a carcass. It's already claimed. Genuinely predatory attacks, a bear deliberately targeting a human as prey, exist in the record, but they're the rare exception, not the rule. Herrero's own analysis found that in the vast majority of documented cases, the bear disengaged and left once the perceived threat was neutralized, behavior that looks nothing like the relentless, hunting predator of popular imagination. Later reviews building on his framework, examining decades of North American incidents, have consistently found that roughly 3/4 or more of serious grizzly attacks fit a defensive profile rather than a predatory one, concentrated overwhelmingly around surprise encounters at close range and females with cubs. That distinction matters because it's almost impossible for a person in the moment to tell which kind of encounter they're in until it's already happening. An adult male grizzly can weigh over 800 pounds in some populations and stand more than 7 feet tall on its hind legs. Look closely at its shoulders, and you'll notice something most people misidentify entirely: a raised hump sitting just behind the neck. It isn't fat. It's a dense mass of pure muscle, engineered for one job: driving the bear's front claws down into frozen or rocky ground hard enough to dig out a marmot burrow, tear apart a fallen log, or excavate a den in solid earth in a matter of hours. Those claws themselves can run 2 to 4 inches long, permanently exposed, built for digging rather than retracting like a cat's. Combine that muscle mass with a bite that wildlife biologists estimate at somewhere in the range of 800 to 1,200 pounds per square inch, roughly 6 to 8 times what an adult human can generate. And you have an animal that can crush a moose femur to get at the marrow inside. For comparison, that bite force sits well above a large domestic dog's and comfortably within range of an African lion's, generated by an animal that, unlike the lion, spends most of the year with no intention of using that bite on anything larger than a ground squirrel. None of that raw power is what actually keeps this animal alive most of the year, though. That comes down to something stranger: the grizzly's relationship with its own metabolism. For 5 to 7 months of the year, a grizzly disappears into a den and does something that used to be described incorrectly as simple hibernation. Biologists now classify it as torpor rather than true hibernation, a distinction that matters because a true hibernator, like a ground squirrel, drops its core body temperature close to freezing and becomes almost impossible to rouse. A grizzly doesn't. During that period, heart rate drops from a resting 40 beats per minute down to somewhere between 8 and 12. Body temperature falls only a few degrees, and the bear stops breathing entirely for stretches of 25 to 30 seconds at a time, only inhaling again once oxygen levels fall low enough to force it. When that breath finally comes, heart rate spikes sharply before dropping back down, part of what researchers describe as one of the most extreme heart rhythm patterns ever recorded in a hibernating mammal, a jolt so disruptive that when researchers have tried implanting monitoring devices directly into a denning bear's heart or gut to study the process, the bear's body has forcibly ejected the hardware on its own more than once. The animal does not eat, does not drink, does not urinate or defecate for months, while somehow avoiding the muscle wasting, bone loss, and kidney failure that would kill a human attempting the same thing inside of weeks, and while somehow resisting infection almost entirely despite carrying open wounds into the den some winters. Pregnancy runs on an even stranger clock. Female grizzlies mate in late spring, but the fertilized egg doesn't implant right away. It floats, dormant, inside the uterus for months, in a state biologists call embryonic diapause, while the female spends the summer and fall in a feeding period so intense it's simply named hyperphagia. 20,000 calories a day, every day, for weeks. Only once she's packed on enough fat, generally more than a fifth of her total body weight, does her body allow the embryo to implant at all. If she hasn't stored enough by the time she enters the den, the pregnancy is quietly reabsorbed, canceled by her own biology before it costs her anything. It's a built-in failsafe no human reproductive system has anything close to, a body that can end a pregnancy on a caloric technicality, then simply try again next year. That single mechanism explains almost everything else about how this animal behaves in late summer and early fall, including the part of its diet that upends the entire idea of what a predator is even doing out there. Here's what almost nobody outside Yellowstone's own research teams actually knows about this animal, and it reframes the entire apex predator premise from the ground up. Every August, hundreds of grizzly bears in the greater Yellowstone ecosystem climb above the tree line, onto steep, remote, wind-scoured talus slopes above 10,000 feet, and spend weeks doing something that looks almost nothing like hunting. They turn over rocks, thousands of them, one at a time, hour after hour. Underneath, sheltering from daylight, are army cutworm moths, an inch-long insect that migrates from farmland on the Great Plains to cool alpine slopes each summer by the hundreds of millions. A single moth weighs a fraction of a gram and delivers about half a calorie. It sounds irrelevant. It isn't. Researchers using scope observation and scat analysis have calculated that a single grizzly can eat up to 40,000 moths in one day. roughly 20,000 calories, entirely from an insect most people have never heard of. In a single 30-day stretch, that adds up to close to half of the bear's entire annual caloric requirement. First documented by biologists in the early 1980s and studied intensively ever since, researchers have counted more than 50 individual grizzlies feeding at a single cluster of moth sites in one day. Animals that would violently defend a carcass from each other, tolerating close quarters over a food source that isn't meat, doesn't fight back, and covers barely a fraction of 1% of the park's total land area. Put plainly, one of the continent's most feared predators spends a meaningful chunk of its year functioning less like a hunter and more like an extremely large, extremely dangerous anteater. That reframing matters because it changes how you should read every attack statistic that follows. This isn't an animal driven primarily by a need to kill. It's an animal driven primarily by a caloric math problem that never stops running, and humans only enter that equation when a bear is surprised, cornered, protecting cubs, or, in the rarest and most dangerous cases, running low enough on options that a person starts to register as a viable calorie source instead of a threat to avoid. On May 3, 2026, that math turned fatal in Glacier National Park. Anthony Polio, a 33-year-old hiker from Florida, set out alone toward the Mount Brown Fire Lookout Trail, the kind of solo day hike thousands of visitors take through the park every summer without incident. When he didn't return, rangers launched a search, working through the following days as concern grew. They found his remains days later on the trail. An investigation by the Interagency Grizzly Bear Committee concluded the attack was brief, intense, and defensive. A hiker who had likely surprised an adult male grizzly at close range on a blind stretch of trail, with no indication of a prolonged pursuit or predatory intent. DNA testing identified the bear as at least 15 years old, a long-term resident of the park with no history of aggression, no prior conflict record, and no known pattern of seeking out people. It was the first fatal bear attack in Glacier National Park in almost 30 years, since 1998. The bear responsible had, by every available record, spent a decade and a half doing exactly what park officials hope every grizzly does, staying away from people without incident until one blind curve on one trail changed that permanently. For one hiker who never saw it coming and, based on the investigation's findings, managed to empty his entire can of bear spray in the seconds he had, though investigators couldn't confirm whether any of it reached the bear. That same week, 400 miles south in Yellowstone, two brothers, ages 15 and 28, were surprised on the Mystic Falls Trail near Old Faithful by a female grizzly with 2 or 3 cubs. Both survived, airlifted out with serious injuries. Neither incident involved a bear with any history of targeting humans. Both involved people who, by all accounts, did nothing wrong beyond being in the wrong place at the wrong distance from an animal whose first instinct, when startled, is not retreat. Given that reality, the actual, evidence-backed answer to "what do I do if a grizzly charges?" turns out to be counterintuitive enough that it's still not universally accepted, even among people who spend their careers in bear country. Researchers Tom Smith and Stephen Herrero spent years compiling records of real bear encounters in Alaska to settle the question of whether a firearm or bear spray gives a person better odds. Their findings, published in the Journal of Wildlife Management, found bear spray stopped aggressive behavior in brown bears roughly 92% of the time. Firearms told a different story. Smith's data suggested it takes an average of 4 solid hits to actually stop a charging bear, and Herrero, who has personally trained to hit target-sized objects under simulated charge conditions, put the difficulty bluntly: hitting something the size of a baseball, moving at you at nearly 30 miles an hour, swaying side to side, while your own body is flooding with adrenaline, is far harder than anyone assumes from a shooting range. Federal investigators studying decades of real encounters found that people who defended themselves with firearms were injured roughly half the time. People using bear spray walked away unhurt in the overwhelming majority of cases. The math runs directly counter to instinct. The tool that doesn't kill the bear outperforms the one that does. Zoom out from any single encounter, and the deeper story about this animal isn't really about danger at all. It's about how much of the surrounding ecosystem is quietly built on top of it. Along rivers in coastal British Columbia and Alaska, grizzlies pull anywhere from 500 to 700 salmon out of the water in a single season, dragging carcasses away from the bank and into the surrounding forest to feed in peace, away from competing bears. A single spawning chum salmon carries an average of 130 grams of nitrogen and more than 20,000 kilojoules of stored energy, and researchers working a single 250-meter stretch of Alaskan stream calculated that returning salmon deposited over 80 kilograms of nitrogen into that stretch alone in barely a month, most of it hauled inland by feeding bears. What the bears leave behind doesn't go to waste. Biologist Thomas Reimchen spent decades tracing a marine isotope called nitrogen-15 through coastal forest ecosystems, and found it embedded directly in the growth rings of centuries-old trees, sometimes miles from the nearest stream. Along salmon-rich rivers, researchers have found that 40 to 80% of the nitrogen in streamside shrubs and trees originated in the open ocean, carried inland entirely by bears. Sitka spruce trees growing near these salmon-fed sites have been measured growing roughly 3 times faster, in some studies up to 19% more stem growth per year than genetically similar trees a short distance further from the water. Decomposing carcasses dragged into the riparian zone can account for close to a quarter of all the nitrogen present in that soil. As Reimchen has put it, a spider spinning a web at the top of one of those trees is, chemically, carrying salmon in its own body. None of it would be there without a several hundred-pound predator hauling fish carcasses uphill for a snack. That web is thinner than it used to be, and the 2 food sources most responsible for keeping the greater Yellowstone grizzly population fed through the year are both under direct pressure. Whitebark pine, whose fat-rich seeds once fueled bears heading into hibernation, has been devastated across huge portions of its range by mountain pine beetle outbreaks and an introduced fungal blight called white pine blister rust, driven in part by winters no longer cold enough to keep beetle populations in check the way they once did. Some surveys across the ecosystem have found the majority of mature whitebark pine already dead or dying. Cutthroat trout populations in Yellowstone Lake collapsed after the illegal introduction of predatory lake trout in the 1990s, a single act of anglers moving fish between waters that cut off another major spring protein source bears once relied on, with cutthroat spawning stream counts falling by more than 90% in some tributaries within 2 decades. Even the army cutworm moth, the insect responsible for feeding roughly half a bear's annual calories in a single month, depends on a precise, narrow band of cool alpine talus habitat that a warming climate is actively shrinking from both directions, squeezed between rising temperatures below and the physical limit of the mountains above. A 2026 study tracking the moth's migratory range found their available high-altitude habitat overlapping grizzly territory is under measurable pressure as temperatures rise, threatening a food source discovered by biologists less than half a century ago and only fully understood in the last few decades. None of this is a story about one dramatic threat. It's the same pattern, again and again. An animal whose entire survival math, the fat storage, the reproductive failsafe, the willingness to eat 40,000 moths in a day, was built around food sources that used to be reliable, now increasingly aren't, in a landscape where humans are also expanding into the exact terrain the bear needs to make up the difference. What that expansion looks like on the ground shows up clearest in the numbers coming out of Montana and Wyoming right now. Grizzly populations in the northern Continental Divide ecosystem, centered on Glacier National Park, have grown for decades and are now pushing into valleys and foothills the species hasn't occupied in generations. Land that, in the meantime, filled up with subdivisions, ranches, and hiking trails. Wildlife officials describe human-bear conflict as rising in direct step with that range expansion, not because the bears have changed, but because the amount of shared ground has. Retired U.S. Fish and Wildlife Service Grizzly Recovery Coordinator Chris Servhin, who spent 35 years on this exact question, has put it plainly: bears rarely get a day off from having to worry about people anymore, on a landscape where they're already working hard just to make a living. Every ranger who investigates a fatal attack in this landscape is, in a very real sense, investigating the same underlying question the moth researchers and the salmon researchers are asking from a different angle. What happens when an animal this finely tuned to a specific set of food sources has to keep improvising as those sources keep moving, on a shrinking map that humans keep filling in from the other direction? The grizzly didn't evolve to be a symbol of wilderness danger, even though that's the role it plays in most people's imagination. It evolved to solve one extremely specific problem: how to build and maintain an enormous, powerful body in a landscape where the food supply is wildly unpredictable from one season and one year to the next. The hump of muscle, the delayed pregnancy, the moths, the salmon, the ability to functionally shut down organ function for months without damage. Every one of these traits is a piece of that same solution, refined over hundreds of thousands of years against a landscape that, for nearly all of that time, gave the bear enough warning and enough margin to adapt. That margin is what's shrinking now, faster than the biology built on top of it ever had to account for. And whatever happens to the grizzly over the next few decades, as its food sources shift, its range expands into occupied land, and encounters like the one on Mount Brown Trail become either rarer or more common, will say less about whether this animal is dangerous than about how much room is actually left for something this specifically adapted to keep improvising its way through a world that no longer runs on the schedule it evolved for.